Right now, at this exact millisecond, your physical body is made up of, well, trillions upon trillions of subatomic particles.
Oh, yeah, countless.
And mathematically speaking, they basically refuse to make up their minds.
Right.
They are just vibrating with this infinite chaotic potential. And according to, some of the greatest minds in quantum physics, one of those mathematically sound potentials involves a version of you right now sitting on the deck of a mega yacht as a billionaire.
I mean, that sounds pretty nice, honestly.
Right, just because they made a wildly different set of choices in their life.
It sounds like pure, unfiltered science fiction.
Totally.
Like the kind of thought experiment you have late at night that usually involves, I don't know, time travel or magic portals.
It really does. You hear that setup and you immediately think of like a comic book movie where the hero has to jump through a glowing wormhole to meet their evil twin.
Exactly.
But we are setting aside the Hollywood special effects today. We're looking at this brilliant set of notes from Ziko's Space Stories.
Which is such a great resource.
It is. And our mission for this deep dive is to shatter that comfortable illusion of a single reality. We are going to look at the rigorous, mind-bending, and entirely legitimate science of the multiverse theory.
Which is such a fantastic starting point, I think. Because when you actually strip away the pop culture tropes and you force yourself to look at the raw cosmology and the foundational quantum mechanics, the reality of the multiverse is something much stranger.
Oh, absolutely.
And like far more awe-inspiring than anything a screenwriter could invent.
Yeah.
We're talking about mathematical models that the most disciplined physicists in the world are currently using to explain our existence.
Okay, let's unpack this. Because if I'm going to buy into the idea that there is a billionaire version of me, or a version of you who took a different job,
Right.
or even a version of the listener who decided to learn French instead of Spanish, we really need to understand the mechanics.
We do.
So Ziko's notes start by exploring the sheer, incomprehensible scale of space. They introduce this thing called inflationary cosmology. And I want to get the mechanics of this right, because we aren't just talking about a big empty room, are we?
No, we definitely aren't. To really grasp inflationary cosmology, I mean, we have to look at what happened a fraction of a second after the Big Bang.
Okay.
The universe didn't just drift apart lazily like smoke from a fire. It underwent this period of violent exponential expansion.
So it's pushing outward.
Yeah, but space itself stretched at a rate that just breaks human comprehension, all driven by a state of repulsive gravity.
Wait, so it's not that galaxies were just flying away from each other through an already existing space.
No, not at all.
The actual fabric of space between them was multiplying and stretching?
That is a crucial distinction. The space itself is inflating. But here is the critical mechanism. It didn't stop inflating everywhere all at once. The theory suggests that the inflation is eternal. It's happening continuously in the grand background. But locally, little pockets of space sort of drop out of this rapid inflation.
I was actually reading this part of the material, and the visual that popped into my head was like a pot of boiling water.
Oh, that's good.
Right. You have this rolling, chaotic medium, and inside it, individual calm bubbles form. Am I getting that right?
That is a brilliant way to visualize it. Our universe, meaning everything we can see with our most powerful telescopes.
The galaxies, the stars.
Exactly, the billions of galaxies, the cosmic web, the entire observable sphere we call our Hubble volume. That's just the inside of one of those tiny bubbles that stopped inflating.
Wow, just one.
Yeah, and it's floating in a vast, endlessly boiling ocean of other bubble universes, which are constantly forming.
And I guess the key operative word for that boiling ocean is infinite, right?
Yes, infinite.
It never stops. There is no edge. Which, I mean, that leads us to the math, because infinity does deeply weird things to probability.
It breaks our intuition completely. I mean, human brains evolved to understand finite things, you know?
Right, like how many apples are on a tree.
Exactly. Or how many miles to the next town. We are just not equipped to internalize true infinity. But the mathematics of it are inescapable.
Because it just goes on forever.
Right. So if you have an infinite amount of space filled with a finite number of particle arrangements, those arrangements are mathematically forced to repeat.
Let me see if I can translate the mechanics of this into something grounded.
Sure.
It makes me think of shuffling a deck of cards. You have a standard deck, 52 cards.
Okay, I follow.
Now, there is a staggeringly massive number of ways you can shuffle that deck. The combinations are huge, right? Something like 8 times 10 to the 67th power.
Yeah, an astronomically large number.
Right.
But, crucially, A limited number.
Exactly. It has an end. So if you sit at a table and you shuffle that deck and deal it and shuffle and deal it, and you do that an infinite number of times,
You're going to run out.
eventually you must run out of new combinations. By pure mathematical necessity, you are going to deal the exact same sequence of 52 cards twice. You have to.
Right.
So is our observable universe basically just an infinitely shuffled deck of matter?
What's fascinating here is how flawlessly that logic maps onto the cosmos.
Yeah.
Instead of 52 cards, you just substitute the fundamental building blocks of matter.
Okay.
You have a finite amount of space in our bubble, our Hubble volume, and a finite number of quantum states or particles that can fit inside it.
Right. There are only so many ways you can arrange, like electrons, quarks, and photons, before you simply run out of new designs.
So if that background ocean of boiling space is truly infinite, probability dictates that the deck of our universe must be dealt again.
Wow.
If you were to build a theoretical spaceship capable of traveling outside our bubble and traversing that infinite void, you are mathematically guaranteed to eventually stumble into a bubble where the particles are arranged in the exact same pattern as ours.
Meaning literally an exact copy of the Milky Way. An exact copy of our sun. An exact copy of the listener sitting right there, listening to an exact copy of this deep dive.
Down to the spin of the very last electron.
Yeah.
But, the source material highlights the really fun implication of this infinite shuffling.
Oh.
You don't just get exact copies, you get every single possible variation.
Oh, because of all the random changes.
Exactly.
Right.
Because of tiny random quantum fluctuations over billions of years, you are going to find a duplicate world that is 99.9% identical to ours, but with completely altered histories.
So it's the same Earth, but, I don't know, the asteroid missed, and we have intelligent commuting dinosaurs.
Well, sure.
Or it's the exact same Earth, but yesterday you decided to wear a blue shirt instead of a black one. In an infinite system, every arrangement of matter that can exist must exist.
It is an absolute mathematical certainty. If the inflation is eternal, all possible histories are playing out in distant bubbles right now.
That is just a staggering concept, but I have to admit it also feels incredibly distant,
How?
Well, it's a matter of immense geography. Knowing there is a duplicate of me trillions of light years away across this uncrossable cosmic ocean, it's cool, but it doesn't really affect my daily life. It's too far away.
That's fair.
But the notes from Ziko Space Stories don't let us off the hook that easily. Is there a mechanism that brings this closer to home? Does the universe ever duplicate locally?
It does. And to understand how, we have to pull back from the macroscopic vastness of deep space and zoom all the way down to the microscopic.
Okay, zooming in.
We're leaving inflationary cosmology and entering the realm of quantum mechanics, specifically the famous many worlds interpretation, first proposed by physicist Hugh Everett.
And this is where the theory shifts from being about cosmic distance to being about microscopic decisions, right?
Exactly.
So to understand the many worlds interpretation, we need to talk about superposition, the idea that particles don't actually have a fixed state until we look at them.
That is the core puzzle of quantum mechanics. At the subatomic level, a particle like an electron doesn't exist in one specific place with one specific trajectory.
It's fuzzy.
Yeah, it exists as a wave of probabilities. Think of a coin spinning rapidly on a table. While it's spinning, it isn't heads and it isn't tails. It is a blur of both possibilities simultaneously. That is superposition.
But obviously when the coin finally falls or when a physicist, measures the electron, it picks a state. The spinning stops.
Right.
The traditional explanation is that the act of measuring it forces the universe to choose, right? The wave of probability collapses into a single concrete reality.
That is the traditional Copenhagen interpretation, yes.
Yeah.
The wave function collapses.
Yeah.
But Hugh Everett looked at the mathematics of quantum mechanics and noticed something profound.
What did he see?
The math doesn't actually contain any mechanism for a collapse. There is no mathematical reason why measuring a particle should force it to delete its other options.
So if it doesn't collapse, where do all those other options go?
Everett proposed that they don't go anywhere. The spinning coin doesn't choose heads or tails. Instead, the universe itself splits.
Wait, literally splits.
Yes. The particle lands on heads in one reality, and it lands on tails in a newly created parallel reality. Both outcomes happen, just in separate, newly branched universes.
Okay, I want to try another analogy here to help visualize this splitting.
Let's hear it.
It makes me think of a giant Plinko board, like from a game show. You drop a plastic chip at the top, and it hits a peg.
Right, Plinko.
In traditional physics, it bounces left or right, and the other path is lost forever. But in the many worlds interpretation, when that chip hits the peg, it's as if it duplicates into two ghost chips. One goes left, one goes right.
Yeah, perfect.
And every time they hit another peg, they split again, taking every possible path through the board simultaneously.
That is an exceptionally elegant way to picture it. The universe is the ultimate Plinko board, and there is a version of reality for every single path the quantum chips can take.
But I need to jump in here and push back on behalf of anyone listening who is, trying to bridge this gap.
Go for it.
Because I can totally follow the Plinko analogy for a subatomic photon hitting a mirror and going left and right. That's the microscopic world.
Sure.
But Ziko's notes argue that this scales up to us. That my decision to cross the street, or I don't know, my decision to have oatmeal instead of eggs for breakfast, literally fractures the cosmos.
It sounds wild, I know.
It really does. How does a tiny, spinning, subatomic coin dictate human behavior? It feels mathematically exhausting to suggest a breakfast choice spawns a whole new universe.
That is actually the most common and fiercest pushback, even among physicists. It feels like there should be a hard boundary between the weird quantum world and our everyday macroscopic world.
Right.
But if we connect this to the bigger picture and dig into the biology of a decision, that boundary vanishes. What is a decision, physically?
Well, it's my brain working. Synapses firing.
Yes. And a synapse firing relies on neurotransmitters. The release of those neurotransmitters is triggered by ion channels opening in your cell membranes.
Okay, we're getting cellular.
We're talking about individual calcium ions moving across a barrier. And a single calcium ion is subject to quantum mechanics. It can exist in a superposition of states.
Oh, wow, wait. So you are saying the ion can simultaneously be in a state of crossing the membrane and not crossing the membrane?
Precisely. If that ion is in superposition, then the neuron is in a superposition of firing and not firing.
Oh, I see where this is going.
Right. And if that neuron is in the critical decision-making pathway of your brain, your macroscopic choice is directly entangled with that quantum event.
Which means my brain is essentially a quantum branching machine.
Exactly.
The microscopic Plinko chip hits the peg, the ion both crosses and doesn't cross, and my brain cascades that split upward into a physical action. In one universe, the neuron fires, and I choose the oatmeal. In the newly branched universe, the neuron doesn't fire, and I reach for the eggs.
Micro cascades into the macro. And it's not just your breakfast, this every interaction in the atmosphere, every photon striking a leaf, every synapse firing in every brain on Earth.
That's a lot of branches.
Millions of these cosmic branches are growing every single microsecond. It creates an unimaginable tree of realities where every physical possibility plays out.
It is deeply terrifying to realize there is an active branch of reality where I basically made every single wrong choice in my life.
Oh,
Yeah.
yes, but also an active branch where you made every right one, where everything aligned perfectly.
Okay, this brings me to a massive hurdle, and it is the next logical question anyone looking at the source material is going to ask.
Which is?
This all sounds like beautiful, intricate theoretical math. It sounds like high-level philosophy.
Yeah.
But can we actually prove any of this? If we're permanently locked in our own branch or stuck in our own distant bubble and we can't observe the others, is it really science?
That skepticism is totally justified. For decades, the prevailing attitude was that contact or observation across these branches or bubbles was fundamentally impossible.
Right.
The multiverse was considered mathematically inevitable, sure, but scientifically unprovable.
But that attitude is shifting, isn't it? Because the source material brings up a phenomenal piece of physical evidence. Astronomers have been examining something called the cosmic microwave background radiation, or the CMB.
Yes, they have.
And they might have found a fingerprint.
The CMB is one of our greatest cosmological tools. To put it simply, the CMB is the thermal afterglow of the Big Bang itself.
The leftover heat.
Exactly. It's a faint shell of radiation that fills the entire universe, dating back to when the cosmos was just this hot, dense soup of plasma about 380,000 years after its birth.
Which is super early in cosmic terms.
Very early.
Yeah.
And by mapping the tiny temperature variations in this radiation, astronomers essentially get a baby picture of the early universe.
Here's where it gets really interesting, because when they mapped this baby picture, they didn't just find standard random temperature fluctuations, did they?
No, they didn't.
They found a massive glaring anomaly out in deep space. They call it the cold spot. It is an enormous region of space that is significantly cooler than all the radiation surrounding it. And the traditional models of physics just struggle to explain why it's there.
It's the magnitude of the cold spot that makes it so perplexing.
Hmm.
It is simply too large and honestly too cold to have formed from the standard chaotic fluctuations of the early universe.
It shouldn't be there.
Right, the math doesn't easily allow for a random void of that scale.
Which opens the door to a mind-blowing hypothesis from cutting-edge physicists. They suggest this cold spot could be a literal cosmic bruise, a physical scar left on our universe.
Let's connect this back to our very first concept, the infinite ocean of boiling bubble universes.
Because of boiling pot.
In a busy infinite ocean, those bubbles are expanding. What happens if two inflating bubbles happen to form too close to each other?
I mean, they would physically bump into each other, but how does two universes colliding create a cold spot? Why wouldn't a collision generate heat?
Well, think about stretching out a hot elastic balloon. If something bumps into that balloon while it's inflating, the two surfaces interact gravitationally.
Okay, they pull on each other.
Yes. As the two universes pull on each other, energy is siphoned away from the plasma in that specific region to fuel that gravitational tug of war.
And in astrophysics, when you pull energy out of a system, the temperature drops.
Exactly. The gravitational pull of the neighboring universe dragging against ours would leave a localized, cooler region in the plasma, a dent where the energy was drained.
The sheer scale of that is almost impossible to picture. Two entire universes containing the seeds of billions of future galaxies brushing up against each other in the cosmic void.
It's a little tap.
And it left a thermal dent that we can actually observe with our satellites today.
It fundamentally shifts the multiverse from a fun, abstract thought experiment on a whiteboard into the realm of observable empirical astronomy.
It's real evidence.
Right. If that cold spot is truly a cosmic bruise, it means the mathematical doors to the multiverse are cracking open. We might literally be looking at the physical footprint of another reality.
It is physical evidence that we are not alone. And not just in the search for alien life, but in terms of entirely different foundational realities existing right next door, pushing up against the fabric of our own space.
It demands a complete rewrite of our understanding of our place in the cosmos.
It really does. So what does this all mean for us? We've traveled from the unimaginable vastness of infinite bubble universes driven by inflation, down to the microscopic neurological fracturing of reality with every choice a calcium ion makes in our brains.
It's quite a journey.
And we've even looked at the thermal bruising of universes colliding. Ziko's Space Stories brings it all back to a core takeaway, and I think it is a profound one. The multiverse theory is the ultimate reminder that reality is far grander, far more complex, and far stranger than we can ever comfortably comprehend.
I would actually take that a step further and leave you with a paradox to mull over as you process all this.
Oh, I love a good paradox. Let's hear it.
If the many worlds interpretation is indeed true, and every possible quantum outcome cascades into a physical reality somewhere,
Yeah.
meaning there is a universe where you failed, and one where you succeeded, one where you acted with cruelty, and one where you showed incredible kindness, does that make the choices you make right now less meaningful? Because after all, everything happens somewhere.
That is the existential trap, isn't it? Like, why put in the effort to study or be kind or build a career if there is mathematically guaranteed to be a version of me already doing it flawlessly in another branch?
Exactly. It can easily invite nihilism, or does it make your choices infinitely more meaningful?
How so?
Because while the mathematics might require all those branches to exist somewhere, you are actively steering the consciousness of this specific localized version of you.
Oh, wow.
You are navigating this exact timeline. You cannot control the infinite sprawling tree of branches, but you are the absolute master of the single fragile branch you're experiencing right now.
That is an incredibly empowering way to frame it. You are steering the singular ship of your own subjective consciousness through an infinite ocean of mathematical possibilities. It really makes you stop and reevaluate the weight of your next decision, no matter how microscopic it might seem at the time.
It certainly adds a bit more gravity to whether you choose the oatmeal or the eggs.
It absolutely does. Well, we hope this deep dive into the multiverse has given you plenty to chew on as you navigate the complexities of your day. Remember that billionaire version of you out there on the yacht?
They're having a good time.
They might have the money, but they do not have the exact unique perspective you have right now, armed with this knowledge, listening to this. So as you go out and face the world today, keep your options and your mind wide open in this particular beautiful branch of reality.